There are lots of ways to create classes in Kotlin. The most common way is to create what we call a named class, which is a class that has a name. And those are most commonly presented in their own file. So here you can see a series of classes, animal, cat, and dog, which extend animal. And these are all named classes because, as you can see, they are given a name. And again, they exist in their own files. However, classes can actually take lots of different forms. First, you can have other named classes defined in the file of another class. So for example, here I have dog, and I could create another class that I call poodle. And perhaps poodle will extend dog. First, I'd have to make dog open. And now I can access or create a poodle object from anywhere else, assuming that it is within scope. So from my main, I could create a pet poodle object. Alternatively, I could have poodle be defined inside the definition of dog. In this scenario, poodle is now a part of dog's larger namespace. So if I wanted to instantiate a poodle object, it would be dog.poodle. And perhaps another interesting variation of this is that in Kotlin, I can create what's called an inner class. So I can specify that poodle is an inner class of dog. By saying that poodle is an inner class of dog, then it basically means that an instance of poodle will be able to access the properties of an instance of dog. Because of this, it means you cannot instantiate a poodle object without also instantiating a dog object. So when we try to create a poodle object like this, it won't work. We also have to create at the same time a dog object. So these are some of the main ways that you can essentially play around with named classes when you want to define a particular class. And this is a quick introduction to some of the constraints that apply. However, there may be times where you want to create a class, such as we've done here, where we create poodle, that extends another class or potentially implements an interface. But for various reasons, you may not need to have this class be a named class because you do not intend to reuse it. You don't intend to make multiple instances of the object that comes from that class. Potentially, you only want to create one instance of that object. In that scenario, it's possible for you to simply create what we call an anonymous class or an anonymous object, which is basically the object that comes from an anonymous class. To do that in Kotlin, we simply say that we want to create an object. And this object is essentially going to either extend or implement some other class or interface. In this case, if we wanted to create a class that extends dog, then we simply say, this anonymous class that I'm creating that doesn't have a name from which I'm going to derive this object is extending the dog class. So this is now a new class that I'm defining, and I can here override whatever functions are defined in dog and then create my own implementation. And this pet reference is now an object of type whichever class I'm defining here, but that class doesn't have a name. But this pet object is perfectly valid, and I can do whatever it is I want to do with it. I can access the name, I can invoke the talk function, and I can pass this around. So this is very useful if you just want to define a one-off object. Similarly, I could create an instance of a class that implements this interface. Now, indirectly, of course, dog implements that interface because animal implements the interface. But I could create my own anonymous class that implements this interface directly. By doing the same thing, I'll simply say that I'm creating an object of a class that implements the communication interface. Now I don't have any parentheses because I'm not invoking a constructor, and I'm being told I need to add the required functions. So here I'm overriding talk, and now I can add the implementation for talk. And now I have pet, which is an object from an anonymous class that implemented the communication interface. And this object can be passed in any a context that requires a communication object. For example, the speak function takes a communication object, so I can call speak with my pet. And that's perfectly valid.